Okay, here we go. We got 2 examples to finish up. Remember, these word problems are supposed to give you some taste about why we use variables. Are they good examples? I'll be honest, not really. I don't think any babysitter anywhere is using X's and Y's to find their wages. No, I don't believe that's true. But we're going to practice on really easy, familiar ones so that you're ready for the harder stuff when you go to take chemistry or physics or business later on. You'll be ready for those type of courses, okay? Oh, what's happening? I pressed the button. Come on, let's go. Switch pages. The length of a rectangle is 2 times the width of the rectangle. Let X represent the width. You know, any geometry type questions like this, and there's not much in this chapter. You know, at most I'll do rectangles. I think the homework might do a circle or a triangle. You know, we're not going to get too crazy with this because I do a whole chapter on this stuff later. But hopefully rectangles is a shape you're pretty familiar with where you don't need a whole separate lesson on that. So I'm going to draw a little rectangle here with my fancy rectangle thing. And my suggestion is anytime you get a question that's got shapes in it, immediately draw the shape to help yourself visualize what's going on. It says the length is 2 times the width. It says let X represent the width. Okay, so it told me let X represent the width, and I don't want to over highlight again, but I think that's important to know. They said use X for width. So there's X on the rectangle. X is the width. And it says the length is 2 times the width. Well, suddenly I don't like my picture very much. You know, when I started the picture, I thought it was pretty good, but now I'm not too fond of it. So let me just see if I can modify my picture a little bit here. Ooh. Oh, yeah. There we go. I'll put it over here. X. The length is 2 times the width. So if the width is X and the length is 2 times that, what could you write on here to represent that using the X? X times 2. All right? So we don't want to introduce new variables if we don't have to. So this side's going to be 2X. And this side over here is going to be 2X. Can you see that 2X in there? All right. Here, let me switch it over to yellow for you. 2X. So there's 2 kinds of sides. There's X's and 2X's. So it says write an expression to represent the length of the rectangle. Oh, the length. I did that already. The length is 2X because it's 2 times the X. 2 times what the width is. It says write a simplified expression for a perimeter. Now again, I do a whole chapter on perimeter later, but I'm hoping at least rectangles, that I don't need a separate lesson on the perimeter of rectangles. How do you find the perimeter rectangle? You don't need a fancy formula. There are some fancy formulas, but really what are you doing with the sides of the rectangle if you want the perimeter? You're just adding them all up. So, simplified expression, X plus 2X plus X plus 2X. And again, if you remember a fancy formula and you want to use it, or if you've got another plan about how to put these all together, those are all fine. I'm just doing it the easiest way I can think of. But this question doesn't say write an expression. It says write a simplified expression. And when they say simplified, they mean collect up the like terms. Do the best thing you can to collect them up. X and 2X and X and 2X. Those are all like terms. So when I add all this together, what do I get? I start with, well, how many X's are there? What coefficient is on that first X? So that's a 1. And that's a 1. So I'm 1 and 2 and 1 and 2. And I get 6X. But I want to do a little better than that. To get ready for the rest of this chapter and for next chapter, I really should have wrote P equals. That's what we're really calculating here, is the perimeter. So the perimeter is 6 times X, whatever X is. And it's at this point you get frustrated with this whole thing and say, well, how do we not know what X is? Right? Well, wouldn't we know with the rectangle? Wouldn't we know? Well, maybe you won't know for a while, but at some point you will know. And here in C, they tell us, suppose the width is 6. Find the perimeter of the rectangle. Now I can do it. Perimeter equals 6 times the 6. They've given it to me, and so the perimeter is 36. So I wanted to do that whole example so you saw that, yeah, you will eventually know what x is. But until we do, we just use the x's and then we sub in at the end. And what did I forget? Let's just check to see if you remember from grade 8, an important part of this answer. P equals 36 centimeters. Yeah, we always want to have units there in the end. And actually, I won't get too bent out of shape in units in this chapter. You know, but we will eventually when we do measurement. For now, it's more important that you just sort of remember perimeter of rectangles. Questions there? One last example. I know I've been teaching for a while here. More time on this one? Okay. An arena charges $25 for gold seats, $18 for red seats, and $15 for blue seats. Write an expression that describes the total earnings. This might be the best example of understanding why we have variables. What you want to do is, let's say you work at the arena, and the owner of the arena isn't really very good at math. But they want to know how much money they're going to make based on how many people come to the game. They want to be able to look when the game starts at the arena. They want to look out, or when the concert starts, they want to look out and go, oh, there's this many of those people, this many of those people. How much money do I make? But they don't really know how to do the calculations. So what we're going to do is make an expression that shows them exactly what to do. Okay, back to this. Gold seats. It was $25 for gold seats. Let's imagine that there were 10 people in the gold seats. How much money, how would you calculate how much money that would cost? 25 times 10. What if it was 20 people in the gold seats? What if it was 99 people? 25 times 99. So we're not going to do any of that because we don't know how many people are in the gold seats. So we're going to go 25G. Now I wrote that down a little lower because I got to introduce something else. I'm going to leave a little space there. If you don't leave space, that's okay. You can write it off to the side. But I'm getting ready that I want to write something after that. Here we go again. Red seats. Let's say there's 10 people in the red seats. You'd go 18 times 10. If there's 20 people in the red seats, 18 times 20. If there's 99 people in the red seats, you go 18 times 99. But we're not going to use any of those because we don't know how many people in the red seats. So we say plus 18R. Notice I've used G and R, not X and Y. Makes sense. Green, red. Why not use the letters that represent what's going on? Anyone want to take a shot at the last one? I hope I've led you right to it where you're like, oh, I get this now. 15V. Now you see what's beautiful about this expression. Somebody who really doesn't know how to calculate things now could just go, okay, I go 25 times however many people are in the gold seats, plus 18 times however many people are in the red seats, plus 15 times however many people in the blue seats. In fact, you could do some other calculations and say, how many people do I have to have in the seats before I make $10,000? Or how many people do I need in the seats to do that? Some of those calculations went on during coronavirus to go, geez, how many baseball games can we play and make money when there's going to be no fans in the seats? You know, so they had to calculate based on TV revenue and so on if they were going to make any money. Is there any point running a season here? So somebody did some crazy calculations. Okay, I got to tidy this up. I think we should really move on and say that should be E equals. E for earnings. How do you get your earnings? Like that. And you should beforehand state what each variable means. Let G be number of people in gold seats. It changes all the time. In grade 8, did they make you do these let statements for the variables? Didn't come up, all right? It's important to me that you make these let statements and say what you're using the variables for. Do you have to do a long sentence like that every time? Not in my class, you don't. You could go, let R be number of R seats, our red seats. You could even use some quotation marks. Let B be number of blue seats. So it doesn't have to be a long and crazy thing like I'm doing there. I'm just really trying to show what we're trying to accomplish. When you do it, you can certainly shorten that down. Last question before some work time. How much will the arena earn if you have 100 gold seats, 200 blue seats, and 250 red seats? You just sub in. You just say, okay, 25 times the gold seats, which is 100, plus 18 times the red seats, which is 250, plus 15 times the blue seats, which is 200. You're subbing into each one of those. And so here I get 2,500 plus 18 times 250, was it 4,500? And 15 times 200 is 3,000. And I get 10,000. Does anyone got their calculator there to see if Mr. Todd's getting old? Yeah, see it? Therefore, the arena will earn $10,000. Do 25 times 100. Yes, 2,500. 18 times 250, 4,500. Good. 15 times 200, 3,000. 7,000, 10. Yeah, it's right. Any questions about that? These examples are supposed to give you a flavor for why we do stuff with variables. And there's a reason why we're doing all these variables. It's going to take some time before we give you enough algebraic experience where you can actually do some really cool math with it. Certainly by the time you get to see me in grade 12, we'll do some real stuff with this. A little bit right now. Okay, is it clear what has to happen next? The rest of those questions in the worksheet package are yours to work on. If you've got room to squeeze the answer in on the page, you're welcome to do that on this particular sheet. But if you need a separate sheet, you can do that. There's about, how many questions there? 12? And the answers are there, so you can check your answers as you go. So you've got now till lunch. That's like 50 minutes. Well, I'll check in with you. How about that? Let's do 25 minutes, see how far you get on this. And then if you get done that, you can work on your check-in or your assignment from yesterday if you're not done those things. Okay?